minus 7 times x plus 10. And the reason I can jump right into a derivative is it's already y equals, and I have no x up in an exponent. So this is not stuff I've just got done doing on examples 1, 2, and 3. So I'm ready for derivative. So y prime equals, I've got a natural log. How do I take the derivative of a natural log of something? Still that same rule. The derivative of the natural log of u is 1 over u times by the derivative of the u. This whole thing is my u. So it's 1 over 4x minus 7 times x plus 10 times by the derivative of the u. Well, if I look, my u is an x term times an x term. That's a product rule here. Inside of here, I've got a u times a v. So I've got to multiply this fraction by a product rule. So derivative of the u here, this is derivative of 4x is 4, times by, and derivative of this is 0, times by x plus 10, plus, keep the first one the same, multiply by the derivative here, derivative of x is a 1, that's a 0, so that would be all over 1 if I want to keep things lined up. So I'm going to distribute, and there's a 1 there. So let's see, I'll have 4x plus 40 plus 4x minus 7 all over these two. And then in the numerator, I'm going to have an 8x plus 33 all over 4x minus 7, x plus 10. Okay, there's the first way. The second way, hopefully it fits, we want to use a log property to rewrite first. So rewrite using a log property. Then derivative. So we're starting with that same equation, y equals natural log of 4x minus 7 times x plus 10. So which log property can I use to rewrite this? Well, that would be this first one. I've got the log of two things multiplied. I can break that apart into the two separate logs added. So I'm going to rewrite first, no derivative yet. So natural log of 4x minus 7 plus natural log of x plus 10. Now I'm ready for derivative. So y prime equals this derivative first. This is my u, so it's 1 over 4x minus 7 times by the derivative inside here. Derivative is a 4. Plus, now I'm on to the second term. Notice I'm not doing a product rule here because I've got a log plus another log. I only do product rule when I've got two logs multiplied, or two x's multiplied. Here, 1 over x plus 10 times by derivative here is a 1. So I've got numerator of 4 over 4x minus 7 plus 1 over x plus 10. Well, that doesn't look like this answer because here I've got two separate fractions. Here I've got 1. So a little work with some junior high fractions here. I need to add these two fractions together. I need a common denominator. I'm going to go down. My common denominator, I can always get a common denominator by multiplying the two denominators together. So I want the denominator of each of these to be these two things multiplied. So that's 4x minus 7 times x plus 10. Same one over here, 4x minus 7 times x plus 10. Okay, to change the denominator, I got to hit it with a 1. I don't get to change the fraction. All I can do is multiply by 1. So this one, I had the 4x minus 7. I multiplied by the x plus 10. So what I actually need to do is also multiply the top by x plus 10 because I multiplied the bottom by x plus 10. This one, I had the x plus 10. I didn't have the 4x minus 7. So that means I got to multiply the top by 4x minus 7. So I'm actually multiplying by a 1 here and by a 1 here. X plus 10 over x plus 10. So if I do that, the 4 gets distributed here. And I have 4x plus 40. Here I distribute the 1. 4x minus 7. Now that they have a common denominator, I can add the two numerators together because it's just like 1/5 plus 3/5. When you have a common denominator, you just combine the numerators and you keep that common denominator, 4/5. Doing the same thing here. I'm going to add the numerators together, combine them, all over that common denominator. So 4x plus 4x gives me an 8x. A 40 plus a negative 7 is a 33. All over that common denominator, 4x minus 7 times x plus 10. Okay, so they did come out the same. All right, your assignment. These get a little challenging. We're going to spend a couple days here, so we'll get good at it today, and then we'll step it up tomorrow. Should be page 269. Quickies 2 through 10 even. And then we're doing 1 through 23 odd. Okay.